Welcome to Brain Academy. Let's look at the above integral solution. Recall that cos theta equals z plus z raised to power -1 all over 2. But let z equals exponential raised to power I theta. The z dt equals I exponential raised to power I theta. The theta equals the z all over I exponential raised to power I theta, which equals the z all over iz. Integral from 0 to 2 pi of the theta divided by 2 plus cos theta equals integral of the unit circle 1 all over 2 plus, we put the value of cos theta, z plus z raised to power -1 all over 2. That's the value of cos theta. The z all over iz. Simplifying, which equals integral, the unit circle, 2 all over 4 into z plus z raised to power -1 multiplying the z all over iz, which equals integral of the unit circle 2 all over I into 4z plus z raised to power 2 plus 1 dz. From CR equation, let Fz equals two all over I into z square plus 4z plus 1, which implies that's equating the denominator equals to 0, z square plus 4z plus 1 equals 0 by Cauchy's residue theorem. we equate the denominator, residue theorem. Factorizing z squared plus 4z plus 1 equals to 0 using quadratic equation to get the poles. That's the quadratic equation 4ac all over 2a. Where we know that from the equation a equals 1 and the b equals 4, c equals 1. Z equals -4 plus or minus square root of 4 square minus 4 into 1 also into 1, all divided by 2 into 1. By simplifying further, we have equals -4 plus or minus square root of 16 minus 4 all over 2, which equals -4 plus or minus square root of 12 all over 2. Therefore, z equals -4 plus square root of 12 all over 2, or -4 negative square root of 12 all over 2. Z put the Z trying to resolve that. Z equals -4 plus the square root of 12 is 3.146 all over 2, or -4 -3.46 all over 2. Therefore, the poles are Z equals -0.27, -0.27. We can call it alpha, say alpha, or -3.73. We can call it beta, say beta. Therefore, f of z has simple poles, simple poles at z equals alpha and beta. But z equals alpha lies inside the circle, inside C. f of z equals 2 over I. F of z equals 2 over I into z negative minus alpha into z minus beta. Residue of f of z at z equals alpha equals limit as z tends to alpha of z minus alpha multiplying by 2 all over the function I z minus alpha into z minus beta. Z minus alpha cancels z minus alpha. We now have is equals to 2 over I into limit as z tends to alpha. We replace z by alpha of 1 over z minus beta, which equals 2 over I multiplied by 1 over alpha minus beta, which equals 2 over I multiplied by 1 all over, we put the value of alpha, negative, the value of alpha is negative 0.27 plus 3.73. Simplifying further, we have 2 over I multiplied by 1 all over 3.46, which equals 2 all over 3.46I. Okay, by Cauchy's residue theorem, integral of the unit circle of f of z dz equals 2 pi I times sum of residues within the unit circle, which equals 2 pi I multiply by 2 all over 3.46I. Then I cancels I, which equals 4 pi over 3.6. This becomes your answer.